All right, welcome back everybody, and good morning. It's Wednesday morning here, about 7:30. Had a good shower yesterday, and it's kind of foggy, patchy fog this morning, but it's a pleasant day here. What's on the agenda today is we're planning on stripping some of this, start taking some of the mechanisms off and cleaning the chassis. But I know that everybody out there, and I have been curious about some of the resistance checks, especially on the Saturable Core Reactor. So what I've done is, to simplify things, is I've made my notes, and I have took the insert, and I could have printed it off, but I just hand wrote it, and with the resistance, the DC resistance values and the color codes and everything, so that I can do a quick check and write them down. And I did that also for the speaker. I've done it for the transformers, and I think I can check the windings from the tube sockets. I pulled there was two tubes in this, so I pulled those out, so I can check the resistances from the tube sockets of the transformers, and then get a good indication. If you hear a little buzzing in the background, that is my fluorescent light. I apologize for that, but I've started using a different recording system, and my microphone picks up just about everything, and so hopefully it won't be too distracting. All right, so we're going to check the primary of the reactor. I will just call it the reactor. I have trouble saying saturable. Okay. Anyway, but the primary is the red and the blue wire, and it's located on the top side of the chassis on this corner, and the wires come through right around these coils. The coil, or the primary, is labeled L27, and it should have a resistance, a DC resistance of about 2150 ohms, 2150. So let me find the red wire and the blue wire, and sometimes it's difficult with this old wire, but the blue wire comes all the way over to this point here on the tube, I believe. I hope my hands are not in the way. And then the red wire is all the way over to this part of the resistor here. And so we're reading, that doesn't look right, does it? Let me look, make sure we've got it the proper place. Yep, sorry, bumped the camera, I'm sure. Okay, now we're reading 1.977K, which is pretty close. I'm going to call it 1.78K is the primary. I think that's good. Let's go to the secondary, which is a black and a green wire. Now, try not to get in your way. I know you probably can't even see down in there. It's pretty crowded. Looking at this wire, I could probably get by with not replacing a lot of the wire, but I just couldn't. I just don't think it's a good idea to leave it that way. So the black wire goes to this point here, and then the green wire goes all the way and through the chassis and to the top part of the Colorama, the bulb array. So we'll clip it on there, and we have 29.1 ohms, which it's supposed to be 30 ohms. No, that's 28 too. Okay. So I feel good that the reactor is good. Let me set up and we'll check. Well, let's see. We can probably go ahead and check the. Let me pause this and reorient this. Hang on a sec. Okay. I had to reorient me more than I did the camera. But anyway, what we're going to do is we're going to check the high voltage windings of the transformer through the rectifier tube socket, which this uses a 5Z4, and I don't know if you can see this or not, but I've drawn the schematic, and the heater will be between 2 and 8, so we can check that winding, and the high voltage will be between 4 and 6, and the center tap is on the bottom of the 110 ohm, or the very end of the 10 ohm resistor, which I plan on replacing the whole thing, so we can use that as a test point. So let's see about the high voltage winding. It should read about 132 ohms, and that's between pins 4 and 6, and I apologize if I'm in the way. A lot of people feel like I get in the way sometimes, but that's okay. Alright, I'm reading 133 ohms or so, so we'll call that good. And so to the center tap, we will say that it is supposed to be around 66 or so. And this is the end here. So these alligator clips, I guess if you're from Britain or whatever, they're crocodile. But anyway, that end of the 10 ohm should be the center tap of the transformer. Reading 65 ohms, which is good. And let's see, we'll have to go to the other winding again. And I don't know any other way to do this, guys, unless I have a 3-foot probe to stick down in there, and I don't have one. Let's see. There's 69 ohms there. So I think we're in good shape on that part of the transformer. What we're going to check now is the heaters on the other tubes, which they're all in parallel. So I'm basically just checking the transformer windings. Now the way the circuit works, the heaters windings go from ground to pin 2. I think the ground is on pin 7 and pin 2 is the common one that it goes from 1 to 1 to 1, and 7 is grounded. So from ground to pin, I got this written down as 7, but I believe it's pin 2. It should be an ohm or less. Then the other side, and one from center tap to the other winding, is exclusively used on the bulbs of the Colorama, and it should read about 3 ohms, 3.32 ohms, which according to the schematic we can go, and here's a little flex resistors. There's 2 of them, R29 and R30, and I believe they're 15 ohm resistors or so. And we'll look at replacing those. I haven't checked them, but this end of it is this is pin 6, I believe, of the 6C5, which is and some of the newer guys, they used unused terminals of tube sockets as terminal connectors. In this case, pin 6 of the 6C5 has no connection to the tube, so they used it as a terminal strip, basically. And so this particular part is where one side of the filament transformer ties in and goes to the light circuit through this. Apparently Albert was gabbing and ran out of camera memory, so he ended up having to reshoot this part. But basically, to check that winding that goes to the Colorama light should be a little over 3.2, 3.3, something like that. It goes from the chassis ground to the base of this flex resistor, and as you can see, it reads about 4.5 ohms or so. Okay, let's check this speaker out a little bit. Looking at the plug, according to the drawing, this is an earlier plug. The newer plugs were wider apart, and the early plugs, they were close together, these two. So between those two should be the speaker field coil, which should be reading around 460 ohms or so. So let's put that across there and see what we have. Okay, 455. I feel really good about the speaker field coil now. All right, now between this pin on the outside and the center one is the primary of the output transformer, which should be 161 ohms. All right. Let's look at that again. You're saying that's 20K. That's 20K. That's not right. That is not right. Well, let's try the other side, and it's a loop, so it's still 20K. So that tells me that the primary of the secondary transformer, or the primary of the secondary of the output transformer, has a high reading, which tells me that it may be bad. All right, so let's go to the secondary side. Okay, now the secondary has the voice coil, the humbucker coil, and everything in parallel with it. The reading for it should be around 4.5 ohms of the speaker, of the voice coil itself, the voice coil, but it's in parallel with the secondary. So it's going to be, in the secondary is probably around 1 ohm or less. So you know, you put those two in parallel, so you're going to have a low reading. Okay, so let's put it across here, and we are reading about 2.2 ohms. And the voice coil itself should read 4.5 ohms, which I think the secondary and the voice coil is okay. Now, I'm going to do something that I'll probably get chastised for, and that's okay. But I'm going to take these leads off, these alligator leads off. Now I'm on the voice coil and the secondary of this transformer, and I'm going to put 1.5 volts across it and see if we get any sound. Now some folks may not like that, but I've seen people do 9-volt batteries. So let's see if we hear anything. So I think the voice coil is okay. But I think the output transformer is bad. So that's something we're going to be looking at further later down the line. I've hooked back up to that primary of that output transformer. Now it's 14K. So getting erratic readings on that. So I say that it's bad. Okay, let's start taking this thing apart a little bit. I'm going to try something that John from Arkansas on the chassis. I'm going to use some brake cleaner. He has impressed upon me. It looked like he was cleaning up that juke box, and it seemed to work pretty good. Let's do something. Let's cut this cord off. Get this thing out of the way. That's usually one of the first things you need to do. Let's take this mechanism off. I'm just going to go ahead and cut these 3 wires that goes to it, simply because they're going to be replaced. And we know where they're going. I believe this is the for the band switch. It's a very small square head, and I don't have a wrench, and I don't want to booger it. But this socket will, and it I don't think it's going to be on there that tight. So let's, and it is turning. Okay, I didn't want to get the pliers to it, but now in theory this should just slide off the band switch, and that's soldered. That cable is soldered on. Okay, so there's 4 screws here. I think I can take them off. I will use my Harbor Freight nut drivers. I've got my Craftsman up in the where I do the bench work at. I don't want to tear something up that doesn't need tearing up. But I'd like to get that on there. Well, before I do anything, let's, I'll make sure I'm still in frame. My pencil keeps getting in the way. That's a good pencil too. I don't like, it's hard to get a hold of good pencils sometimes. Make sure you're in frame there. Okay, I want to disconnect this drive wheel. Let me see if I can get the camera without making you seasick and get in there and show you. There's 2 set screws on this wheel, and down below is the reduction drive. Okay, so that goes with the condenser, and this wheel should just, after loosening those up, should just slide off with this unit. So let me loosen those screws and see if we can. Let me see if I can loosen those screws first. Let's see. Working with a new tripod also. So, all right, let's see if I can get this little screwdriver. Hopefully this is not very tight, and there should be some witness marks on it. That loosened up fairly well. Let's see about this one. Yep. And let's see. I don't know if it's going to come off that easy, but let's jack the front end up again and get the nut driver involved on these 4 screws and see if this whole thing will come off. All right. I have to give the cameraman a raise there. Yeah, I've got the cheap set of down here, and I got the good set where I do most of my work. But since this was nasty and the workbench is really not cleared off yet, I've got to find a place for that 31. I may have to throw out a chair or something in the house to find space for it. Okay, there's one screw out. There's another screw out. And let's see, we'll put them here, but we'll put those back in there before we lose those. Oops. Dropped it, but found it. So they're all right over here. So in theory, this should lift off, and then this should come off that shaft. Should. All in one piece. And there we are. So I will put that in a nice, neat little box. But, as John always says, let's put the screws back in it. Take our time. I enjoy watching John. And he's right. He's right. We put our time on our own time pressure, like we've got to get this done right now. And that's not true. We can take our time. We can turn the video off if we want to. So there, that is. Now, I think what I'm going to do is I think that I will take that outside and we'll spray it really good with that cleaner. Okay, that's going to wrap this video up. I've got the gunk pretty much off of it, the majority of it. I'm going to let this dry a little bit more. I've also did underneath. Of course, I've still got to do some more cleaning, but this was just the initial, getting the 81 years of gunk off of it. So we'll have to do some more cleaning and address a couple of places I saw that has some rust on it. But we've identified some parts that we need to replace, so I need to do some ordering on that. And so in the next part, we will be further taking it apart and replacing some wires and resistors and caps. Oh my. So anyway, so have a good day. Larry from the hills of Tennessee. Thanks for watching.